Zener as a voltage regulator using LTspice software. Okay, first we will discuss the theoretical part. Then with the simulated output I will explain. Then we will move on to the LTspice with the detailed explanation I will be teaching you today lecture. Okay, so here the concept which we are going to today to discuss here is what is a unique property of the Zener diode. Okay, already you know. And what is the voltage regulator circuit? What is the voltage regulator circuit? And what is the type of regulation? Okay, that is the agenda of the today class. Okay, so let me start with the what do you mean by voltage regulator? So voltage regulator is an electronic circuit that will provide the stable DC voltage independent of the change in the load current or temperature, that is ambient condition, or AC line voltage variation. So this is a voltage regulator concepts. So independent of the variation, your output voltage, that is the output voltage will be remain constant. Okay, that is the concept of the voltage. How it was achieved? Because of the Zener diode. Here Zener diode have the unique property, Zener diode will work in the reverse bias. This is the anode and this is the cathode. Right? We used to say positive or negative, technically anode and cathode. So when it connect in the reverse bias, so in the forward bias we are not going to discuss. In the reverse bias we have a unique property, that is when it reach a like a minimum, that is a breakdown voltage. After that your voltage will be remain constant even after there is a change in the input voltage or current in the Zener diode. So that is a unique property. Your voltage in the Zener diode will be constant after attaining the VZ, that is a breakdown voltage. Okay, it will be specified in the data sheet. When you see any Zener diode data sheet, that will be specified by the manufacturer. So if it is a 8 or 10, exactly that will happen in no, there will be some tolerance. Okay, so ideally we'll say 8. So exactly in the 8, if it is specified, that is the reverse bias voltage, you will be having the your output voltage will be constant even after there is a change in the input voltage or load section. Okay, this only we are going to consider as a regulation, that is a line regulation and load regulation. When you are considering the input is varying, that is a line regulation. So even after the changing the input side, your output voltage will remain constant. How? So that we are going to discuss. So when you go to the load regulation, even after there is a changing in the RL, your output voltage will remain constant. That we are going to see. Okay. So the regulated DC output voltage V0 and VZ. Okay. You can understand your Zener diode will be connecting parallel with your load. Same DC voltage, that is your constant DC voltage will be coupled in your output section as it is connected in the parallel, irrespective of change in the input variation or output variation. That only we are going to discuss in the coming slides. Okay, so what is a line regulation? In the line regulation, I'm going to consider the on assumption. The assumption is input is varying, is changing. Okay, so you can see the arrangement of this circuit, that is a input resistance and output resistance are connected it is series, and respect to the Zener diode it is connect parallel and RS is connected series. Okay, and input voltage is varying, it's varying. Okay, it's denote varying. Okay, the output voltage will be remain constant. That is our concept. The V naught equal to Vz, it should be constant. That is a regulator circuit. How? So you consider V in is varying, RL is fixed. The current in the circuit will be I, there is a total current. So this is a diode, there is another diode current, this is a load current. So I said clearly input is varying. So that means your input current will vary, right? In respect to the change in the either input is increase or down. Okay, that you want to understand. When I is varying, you know that IZ also will be varying, right? So but it should be in the range of IZ minimum and IZ maximum. It should not go above this. That you want to be more careful. IL will be remain constant. Okay, IL will be constant because it is clearly the RL is fixed. So the current across RL will be fixed. IZ will be varying. Okay, but it should be in the range of specified value. Okay, so in that condition your Vz and V0 will be same, so that is called a regulator circuit. Even there is a change in the input section, the output voltage will be remain constant. Okay, because Iz is varying, so there is no problem when Iz is changing with the specified value. So because of this is the voltage will not going to affect, not going to change, because this is a constant. Same voltage will be reflecting here. So that you want to understand how you can determine theoretically, that is the changes of output voltage divided by changes of input voltage. If you want to find in percentage, you want to multiply with the 100. Okay, here I explained with your simulated output. Okay, for the design circuit, this is the output I got, right? So this is your voltage and this is also voltage. So this is nothing but your input voltage, this is your output voltage. Your x-axis is nothing but your input voltage and y-axis is nothing but your output voltage. Here the values are specified. You can see here the variation of the your input is 10 and another range is 9. Okay, you can see this is a one range, this is another range. So the variation in the output side, so that is one range is 8.36, another range is 7.82. This clearly specified. Okay, so I want to find the variation. Here you know input you are varying, the output voltage is remain constant. For that this values are 0.54, difference is 1 into 100, 54% in the line regulation. Okay, so now we'll go for the load regulation. When you go for the load regulation, the input voltage will be fixed. You want to understand, input voltage is fixed. Okay, output resistance is varying, the load resistance is varying with the specified range. Even after you as a change in RL, the output voltage is going to be constant. How? We are going to see. We want to achieve V not equal to Vz, that is a regulator circuit concept. V in is fixed, right? The V in is fixed here. Okay, this is fixed one. The fixed, this I am going to vary. Here you want to understand, when I am saying it is fixed, it's going to be constant, right? The I going to be constant. The IZ, already you know the IZ current will change from the specified value. Okay, it should be in the specified value, that is very important. The IZ, that is a Zener diode current, should be in the range of IZ minimum, IZ maximum. That you want to be very careful. Okay, when you go for IL, so IL was changing because RL is changing. So when RL is changing, the you can understand that the current in the load part also will be varying, right? So it was mentioned clearly the I will be constant, IZ will be varying, IL will be varying. Okay, here it should be in the range of minimum. Okay, so in order to maintain the constant I, it both should be varying. Okay, then only you can maintain I is constant. Okay, then only you can maintain the current as a constant. Okay, so here the formula for finding the load regulation is no load minus full load divided by full load into 100. This is the formula to find the load regulation. Okay, so no load. So to find the no load, what we can do is we can remove the load from the design circuit, then you can find what is the output voltage. Then to find the full load, you can connect the RL and you can find it. So that is the thing I have done here. So this is a simulated output. This for this circuit I have removed the load. For this I have removed the load. You can see here this is a load, this is a RL, this is a diode, and here you have RL. So first condition I have removed and I have taken the output. So that is a constant voltage, you can see that is 8.422. The full load I am varying from the specified range. Okay, over the specified range the voltage is varying. Okay, the output is voltage is varying. Okay, so I'm taking like a 6.643. Okay, I'm taking at the one certain point, that is a 6.43. Okay, 6.643 divided by your full voltage. Okay, 6.643 to 100, you will be having 26 percentage. So you can find for different values. I have taken for only one value to make you to understand. Okay, so this is a concept to find the load regulation and iron regulation with the theoretical calculation. Okay, now we will move on to the uh, LTspice software. Okay, LTspice software. Okay, you open the already designed. Anyway, I will explain step by step here. Here you can see this is the input section voltage. The Zener diode. I have taken BZX84C8 voltage 2L. Here it will provide 8 voltage, constant voltage, that already you have seen in the simulated output. I have shown in the PPT, right? And this is connected to the ground. This is your load resistance RL. It's going to be a constant, and this is your RS resistance. Okay, so here I'll be first explaining here what is the input I given. Okay, see, because we are going to speak only the DC part. Okay, the first source you will be using one source, right? We will be having only one source. So name I just kept V1. Same you should keep here. The type of sweep is linear. You should choose. As you know, it's a linear only. So start value should be 0, and in the line regulation you are varying the input side. So I am varying from the 0 to 20 and increment with the step of 2. So here you can see same you can give, or you can give in the different manner. Okay, the different steps. And RS resistance is 100, and this Zener diode is working at the 8 voltage. Zener diode voltage. RL is 1000. Okay, now save and I'll simulate. Okay, so here you want to see your output. See, when you are seeing the output, you can either you can keep here or here. You have a doubt like I want to keep here or here. See, it is a single node, you can keep anywhere. See, this is a red color. When red color is coming, it says that LTspice, the marker is measuring the voltage. Okay, so you can see here this is your variation of your input voltage. Okay, so this is your output voltage. So from here only I have taken the some specified value I have taken. Okay, so for your understanding I have taken some two values and explain in the slide. Okay, so I will be taking two cursor here. Okay, so one here and I think I have taken exactly 9, right? Okay, so I'll be keeping approximately. So this will keep like a 10. So here you want to measure what is the change, right? So this is your input part which you are varying, and this is your output change in the current. Okay, so output change in your voltage variation, little variation. So that it try to measure what is the regulation part, that is a line regulation. Okay, so I hope you understood. So this is your change in your input side, and this is a change in your output side. So you can measure the what is the change. So you can see change is measured to be slope is 53. So 0.53 into 100, you will be getting 100 percentage, that is a 53 percentage of your regulation output, line regulation output. Okay, so here nothing to explain more than that. So thing is, here you want to change this setting and you want to select, that's it. Okay, so let me go for the load regulation part. Okay, so let me close this. So let me close this also. So I open the load regulation. The load regulation, already you know, the load resistance I am going to vary. Okay, the input section is going to be constant. Okay, in DC voltage is constant. Okay, so I can directly mention there is no sweep is required. So 10 voltage is just specified. Okay, 10 voltage is specified. Okay, it's going to be constant. This is series resistance RS. Okay, if you want to confuse, even you can change this RS. Okay, 100 ohms, and this is your Zener diode connected in the reverse bias. So it's working at the 8 voltage. Okay, here the thing is RL is varying. So you want to, what you want to do is RL you should put in the flower basis. Okay, so you want to specify the value here. Okay, so flower basis you want to put RL, and see when you take any resistor, see you will be having like this. Okay, this one you should not change. Okay, you want to comment here only in the R only. I have written this flower basis RL. Okay, so let me remove this. People will make a mistake, they will change in the R1 part. Okay, so this one you should not disturb. This is a variable you should not disturb. Okay, this is a reserve command. Okay, so when you change, when you put in RL, so what you want to give this one command is, so okay, so go to the spice direct. Okay, so you can go here. So right click and go to the, you can see here in the draft you can see the spice direct. Okay, in the spice direct you can type dot step param RL, that is a resistance varying with the step of 100 from 1 to 1000. Okay, so this is a command you want to give, like a dot step param RL 1 to 1000. You can give any range. Okay, just for your understanding I'm just given. Okay, it will be coming like this. So already I have given, so I'll just remove this. Okay, so that's it. So no more nothing to explain. So we'll go for the simulated output final. Okay, so here this is a very important. I explained this command, that is a dot step param RL 1 to 1000 with the step increment of 100. It should be represent the flower basis. Okay, so let me save and run it. Okay, so you want to see output, so just click it. See, first what you want to do is you want to measure without load, right? So what I will do, I will remove this load part. So this is very important. People are confusing here how to measure. So I remove this condition, that is a no load I can measure. Okay, when you run this, okay, you can see you have a constant output voltage. So this is a range that you are obtaining for this regulator. So the output constant voltage is 8.422. Okay, that is voltage you should take for the no voltage condition. So now let me give the RL. Okay, so let me give the RL here. So I hope you understood. Okay, students are confused in this part only. I explain here clearly. Okay, so now again I will save. I will run it. So you can see the output voltage is varying with respect to the resistance. Okay, so you can take a cursor. Okay, you can keep a cursor and you can measure first some specific resistance and you can note down. This is with load. The previous one which you obtained, right, that is a something 8.44, that is a no load voltage. So this is a with the load. So you can take for any value and you can measure the regulation. Okay, just for example I have given here, I have taken only this point. You can take at any point and you can measure what is the load regulation. Okay, so here thing is the node, when you are measuring the no load you want to remove the RL and you want to measure. That is a thing you want to understand. Okay, so some students will take like a input voltage thing. Okay, they will be making wrong, misunderstood. Okay, so here you want to remove this RL and you want to measure, that is your output voltage when you are not connecting the load. That is a perfect. Okay, thank you. So if you have any doubt, you can post in the chat box. Thank you.